every day, and it's just like more and more and more. But God bless. What we're doing now is really, for the most part, not new stuff. It's applying older stuff. So we're just going to continue to push through, continue to crank it out. I think I mentioned at this rate, it looks like 9 class days for review only. But every night the homework has mostly review stuff on it. And once we roll around to, I'd say, mid-May, we start really spending a lot of focus on practice regions questions that are on your homework. So let's go through and read. Look, this is just, it's about analyzing graphs. It's about looking at data and sequences and seeing what information we can possibly gather or garner from the particular stuff that they're going. So it says here, read the problem below. And it talks about the relationship between the length of a leg of an animal and in feet, and the animal's walking speed, not running speed, walking speed. So it makes this particular graph, and 3 points on the graph that are worth noting: 0, 0, 2, 8, and what's the other one say there? 416 maybe? 816. Okay. And then it says a T-Rex's leg has a length of 20 feet. What is his speed in feet per second? Anybody think they got it? Andre?
26 feet per second.
Let's see. Well, here's a length. This is, the speed goes this way, and this is the length of the leg. So here's a leg that's 20 feet long. Oh. Okay, here we go. Here's the length of a leg that's 20 feet long. It goes up to here. And this tells me that it's
25.
I would
26.
yeah, 24, 5, 6, something like that. Anything in there is good. What did you say?
26.
Yeah, anything in that area is good. Okay. Any questions about that? So the first question was real simple. Can you interpret the graph? Is really what they're getting at. If you can interpret it, it's pretty easy to go. How many people got that right? Okay, good. Thought that was pretty straightforward. What do you, the 3 girls over there, did you all get it wrong, or are you just morally objecting to answering questions today? Do you get the idea that they are not into it? By now, I've usually had to collect a spit bucket of drool from one of them. The other one has complained 22 times that she really deserves Oreos, or that she wants to open and watch it forever. Savannah's normally quiet, so this is normal behavior for you. All right. Next. During the tryouts for the track team, Bob's 90-foot wind sprints. We talked about this the other day. Time t equals 0 is at the starting line, accelerates opposite wall, turns around, runs back, blah, blah, blah. How far was Bob from the starting line at 2 seconds? So how far was he from the starting line in 2 seconds? Leanne?
50 meters.
Let's see. 2. Yeah, I'd say right around 50.
But it says 90 feet.
Well, 90 foot is the whole wind sprint.
Yeah, so
But they're saying at 2 seconds, how far is he? Not from the far wall, right? Where the opposite wall. His starting line already. Slow down stuff. Oh, it's down here. How far was he from the starting line? If it said how far is he from the finishing line, then it would be 40 feet.
No, but how is it meters?
Oh, did they write meters instead of feet? Typical Common Core stuff.
So
All right.
meters
I don't think they're looking for you to turn around and convert feet to meters.
To the nearest tenth.
Oh, okay, so this is feet?
Yeah.
Oh, God, so I gotta convert feet to meters? Okay, so 50 feet. Does anybody here happen to know how many inches is in a meter?
For inches. A one. I was kidding.
39.37.
Yeah.
Yes, I didn't think any of you would know that, but that's the truth.
I want to say 30 feet.
39.37. So here's what we're gonna do, ready? 50 feet, I gotta multiply that by 12, that gives me, what, 600 inches? Right? You with me on that?
No. I'm pretty sure that is meters.
But it says 90-foot wind sprints, and that's a 90, so that has to be feet.
And then it says feet on the left.
Yeah. So it has to be feet. Okay, now, there's a total of 600, there's a total of 600 inches, and I need to divide that by 39.37, and whatever 600 divided by 39.37 is, is going to give you your answer. I believe they say here round to the nearest tenth.
15 and 24, 24.
So it's 15.2. Why they have to do that, I have no idea. Maybe they think they're tougher doing that. I don't think too many kids walk around with the fact that a meter is 39.37 inches
I know it's 39.
stuck in their head.
I thought a meter and a yard were like the same length.
Yeah, I did
A
too.
yard's 36 inches, a meter is 39.37.
So it's 3 feet. Wait, how did you do 6.5?
So it's, a meter is a little longer than a yard,
Oh, okay.
okay?
You didn't do 6.5.
What's that?
It's the same. 6.5 seconds.
Do the same process,
Oh,
okay? All right, a soccer coach is getting her students ready for the season by introducing them to high-intensity interval training. Dun, 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 dun. Sounds like CrossFit, kind of. She presents the table below with a list of exercises for an HIIT training circuit and the length of time that must be spent on each exercise, blah, blah, blah.
Oh, there's two.
Okay, the rest times increase as the students complete more exercise on the circuit. Study the chart and answer the questions below. How long would the 10th exercise be? Okay, so read through. How long is the 10th exercise?
Why did
Okay, what do you think?
Is it 3 minutes?
Let's see. 0.5, I don't think it's gonna be 3, I think it's gonna be a little less. Then 0.75, then 1, then 1.25, then 1.5. What are we going up by?
1.25.
0.25, and this is what kind of sequence?
Uh,
Arithmetic sequence, linear function, okay? Now, let's keep going here. 1.75 is the sixth one, 2 is the seventh, 2.25 is the eighth, 2.5 is the ninth, 2.75 is the 10th. So 2 3/4 minutes long, okay? Now, yes,
I don't think how it's on 3 because there's 5.
because you started at 0.5.
Oh, you started at that? I thought you were like
oh,
added that.
No, you see it going up by 0.25s. To go up perfectly and always be 0.25 or to consider 3, you needed a 0.25 in front of that, and that would get you there, okay? All right, and then it also says here, if a player had 30 minutes of actual gym time during a period, how many exercises could she get done? All right, let me add this and this together. This is 0.75, this is 1.25, this is 2, this is 3.25, this is 5.5. Let's analyze what's going on here. This goes up 0.5, then 0.75, then what? 1.25, then 2.25. Is there an explanation for that sequence? Boy, I don't think so. I guess I have to figure that out the next one. It looks to me like this is a geometric sequence, the rest time,
Yeah.
right? Because everything's doubling. And this one is arithmetic. So my first attempt was to try to combine them and come up with some kind of predictable pattern, but I really can't do that. So at this point in time, let's see what we have all together. All together, we're going to have 2, 4, 7 1/4, 12 1/4, 12 3/4 minutes. So this is 12.75 minutes. And then this one would go up to 1.75, and this would go up to 8. So now I have to add 9.75 onto that, and 9.75 onto that would be 21.5. Okay? And now I have to go to 2 and to what? 16, agree? Because we're constantly doubling here. So that adds 18 onto this, which is 39.5. Oh, see, that's past the 30 minutes. So the maximum they can do is 6 exercises. Because it says they only have 30 minutes of actual gym time in a period. Okay? So they can do 6 exercises. And after that, they've used up all their time. Don't go doing that. So bad. You yawn. As soon as you yawn, you make me yawn. Yes, you did. You don't even know that you yawn? You absolutely yawn. How bad is that? You're so bored you don't even know when you're yawning. That's like pathetic. Okay, next up, determine whether the sequence is arithmetic or geometric and find the function that will produce any term in the sequence. Ooh, this one looks like fun. Go ahead. Now, they kind of give you a hint in that they say it is either arithmetic or geometric. It's always, in my opinion, easy to tell if something is arithmetic or not. Not always easy to tell if it's geometric. Well, it is easy to tell if it's geometric, just
Wait,
it's not always
what
easy
are
to
they
figure.
talking about?
Yeah, the length.
This one right here.
Oh, that one.
Yeah. So, is it arithmetic? Yes or no? No. Is it geometric?
Yeah.
Yes. Now, how can you tell that it's geometric? Well, let me even backtrack one step further. How can you tell it's not arithmetic?
Like by a constant.
Right, there is no constant difference here. This is 8, this is 12, this is 18, that's not going to work. So this is a no to arithmetic, and then we say yes to geometric. And Leanne, how did you tell it was yes for geometric?
Because it doesn't go up by the same amount of numbers.
Yeah, but the problem with that is that that doesn't necessarily mean it's geometric. It means it's not arithmetic. So if you're saying, well, they only gave us 2 choices on this one, so it had to be geometric. Usually they give you 3 choices, arithmetic, geometric, and neither. Your technique would not have worked if it was 3 choices. But with 2 choices, I can go with that somewhat slightly bitsy lazy approach. Does anybody have a better reason why this has to be geometric? Oh, it's so easy to answer. Listen, what is the definition of a geometric sequence? What does it always have? A constant ratio. So what's the only way to show if it's geometric? Constant ratio. What is 81 divided by 54? Put it on your calculator.
1.5.
1.5. What's 54 divided by 36?
1.5.
36 divided by 24, and so on. So yes, it's geometric, and the constant ratio is 1.5. Now that's kind of weird because usually it's numbers we would recognize, right? Like doubling it or tripling it. Now we're going a ratio of 1.5. But the test is still the same. 81 divided by 54, 54 divided by 36, 36 divided by 24, 24 divided by 16. Make sure you come out with the same number every time, which you will. It's 1.5. Now, what is the analytic representation of this sequence? It's y equals 16 times 1.5 to the n minus 1. Does anybody remember why it has to be n minus 1 and not n? Because? Is that like some great cosmic truth? Because. It's a smile. Happy. Andre,
Because it's the term before it.
what do you mean? All right, here's the deal. One of the ways to test out your theory is to test your answer. Let's say you thought it was just n. Let's see if it works for the first term. If it was just n and no n minus 1, and I plugged in a 1 for n, I would get 1.5 to the 1 times 16. And that would work out to be 24. So that puts us 1 term ahead. So I have to go a term back, and the minus 1 puts me to a term back. Now let's plug in the 1 again for the first term using n minus 1. What's 1 minus 1? 0. What's anything to the 0 power? 1. And what's 16 times 1? 16. So it is frequently the case with a geometric sequence that we're going to have to use an n minus 1 in the formula. We did that with the recursive formulas. Remember, we often needed the n minus 1 instead of just n. Molly?
How do you know what the n is?
Well, the n's work out to be terms. This is the first term, second term, third term, fourth term, fifth term. So any term can be given by this formula. If I want the 10th term, I plug in the 10th one. And listen, how do I know 16 has to be in there? Okay? It's the first term. Because ultimately, we're going to get a 1 out of this term. So I have to have the first term here, so when I multiply it by 1, I keep that first term. Okay? Any questions? All right. I think that's it. Let me just double check. Right, is there homework next? No? Okay. All right, take a look. What kind of sequence is this, guys? Arithmetic. Now, here's the question. I love when they ask this kind of question. How much would 1,000 hours cost? The problem with this is, do you really want to write this out to 1,000 of them? So let's do what we just talked about with the n minus 1 principle. F of n equals 50 plus 2 times n minus 1. And again, I have to do n minus 1 because we're not counting the first term. Now, let's just double check and make sure this works. Let's do the fourth term and make sure we get 56, okay? If I plug in a 4 here, what's 4 minus 1? 3. What's 3 times 2?
6.
And what's 6 plus 50?
50.
And that's what I was supposed to get. So I know I got my formula right. I always double check that formula. Now, for the 1,000th term, I'm going to plug in 1,000 for n. So what's 1,000 minus 1? 999. And what's 999 times 2? 1998, right? And then 50 plus 1998 is 2,048. And that would be my answer. So when they ask for these terms that are far off, what you do is you come up with a formula and then you substitute in. All right, folks. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Garushurus. Codifis. Hasta la bye-bye. Sayonara. See ya. Have a good one. Enjoy. Pardon me.